All right, so in our next section here, we're going to talk a little bit more about confidence intervals and estimating means, and we're also going to talk about t-distributions. I guess that's what it really should be. T-distributions and CIs, right? So similar to what we've already learned, nothing new fancy. We already know that for standard error, we're calculating this by finding the standard deviation divided by the square root of n. This is in material that we've already covered. But this section is more concerned about what happens when there is no. What happens if we have a large sample? So in the previous examples and videos we looked at, like we were looking, these are all based off of large samples, right? And so those are going to be greater than 30 people. So usually we say those are greater than 30. But there are going to be some situations where we really can't do that, right? So situations where it's just not feasible to get a large sample. This could be like a survey. So, depending on what it is, it may be like a difficult population to access. It could be super expensive to do the study, period. So let's say, for example, like if you were doing like brain scans of people, brain scans aren't cheap. We really, they cost a lot of time, interpretation, analysis, a lot of health risk associated with that. So we can't just like do that, right? And so, it could also be that, we have poor sampling, like we just can't get a lot of them, or there's a cost issue. So there's a lot of reasons why we may end up with it could also be like if we were interested in studying differences of opinion in like European countries, right? Or only Western European countries. The population of interest could be just really small, right? Because it's not going to be any more than, I think the entire EU is like 40 countries, but if we're only looking at West Europe and not East, that's a pretty small number ultimately, right? And so one way that we do this, right, is that in the past, everything was grounded on the normal distribution. We can still, do our analysis, but we can still analyze data and express uncertainty. So we can still analyze data and express uncertainty with small data. And we use this with the t-distribution. So let's cover like a few things to keep in mind, right? So one thing is, this is similar to the normal distribution. I don't like that color. Do back this. So it's similar to the normal. It's bell-shaped. And symmetric. No big deal there, right? Now the shape changes based off of degrees of freedom, which I'll call df here. And this is basically going to be like df is its sample size, so n minus number of estimated parameters. So let's say an example real quick, that we had a sample size of 17 and I wanted to find the mean, right? the degrees of freedom I have is going to equal 17 minus 1 because I'm estimating one parameter here. And so that means it's going to be 16. So this might seem trivial, but this is super useful and necessary for looking up a t table in the back, looking at t distribution table. So hold on to that idea, right? I don't know that we're going to walk through a table, but that's something that you should be familiar and know for. The other thing that we should know about the t distribution is that we have that it has thick tails and there's more variability than a normal distribution. And there's a few little notes that I have written there about how we look at the appropriate t-values and express uncertainty, though. The good news is that formulas and calculations are basically the same. And so we'll kind of go over that in the next video where we'll work some problems and show just how similar they are.